Good afternoon. We have plenty of space here, so feel free to come up front if you guys like. That'd be great. So a new study by Information Technology and Innovation Foundation indicates that 24% of total internet bandwidth is being used for online piracy currently. And that is up 160% since November 2011, less than 2 years. Other studies indicate that movie piracy costs the US film studios around $25 billion annually. And that is about $2.5 billion in workers' earnings and over 75,000 jobs annually. Wow, big numbers. Hi, my name is Usman Shakil, and I'll be talking about securing media content and applications in the AWS cloud. And I'm really honored to have Ben-Masek from Sony Media Cloud Services. He's the CTO and Vice President at Sony, and he'll be talking about their path to MPAA alignment for their C application. So a lot of my customers used to ask me this question a while back: does AWS meet my security requirements? The answer to the question, obviously, yes. Then a lot of my customers in the media domain asked me, does AWS meet the security requirements for the MPAA alignment? Answer again, yes. We've come a long way in terms of the feature set that we offer at AWS services and products and services. And it's really used to be, the question used to be that what applications I can really host or use AWS or the cloud for. It's really become a question of how can I move these applications and what is it going to take to move these applications over to the cloud? So really, a better question to ask is, what can we do together, you as a customer, AWS as a vendor, to ensure that your applications and content are secure on the cloud? Security is priority number one within AWS. We treat the security and privacy of our customers very, very seriously. If we have any indication that things are going wrong or chance of things going wrong, we drop things to take care of the security and privacy of our customers. Very important people do get paged if there is anything, any sort of an issue. But more than that, it's all different types of customers. This sort of security and privacy and importance for that is for all different types and sizes of customers. All different verticals, large or small. If it is somebody's files, photos, other files they have on us, or Hollywood's most valuable assets on the cloud, it is all treated through the same security lens. So media IT today is basically faced with a lot of constant pressures from many different directions. That could be constant pressures around from the business itself, that they want better vendor relationships to shorten the procurement cycles, to cut down on the costs, for audits and compliances, to take care of the cost of business in terms of infrastructure management, infrastructure security, infrastructure audit, disaster recovery, high availability, or to also focus on the core differentiators and to really fulfill the needs of their customers. Customers be internal customers or external customers, to provide better customer experiences, reach more and more customers, and more cool features. But the budgets stay the same. So your dollar is really stretched at the end of the day. And it's a choice that you have to make. That is, to use that dollar for the cost of infrastructure management or the muck, undifferentiated heavy lifting, where you're taking care of infrastructure management, security of infrastructure, audit, DR, HA, all those things, or really focus your energy and your budget towards the core differentiators, producing new product features, better customer experiences, and reaching more customers and making your customers really happy. So security within AWS works as a shared responsibility model, where anything and everything from the infrastructure security perspective, AWS takes care of it. And it'll be right to say that really from the dirt of the data center itself all the way up to the virtualization infrastructure, that includes the facilities, the physical security of the facilities, the physical infrastructure of the underlying servers that we have, the network infrastructure, and the virtualization infrastructure. All that is Amazon Web Services responsibility. So what that means then is all the applications that are running on the AWS infrastructure then, at the starting from the network configuration itself at the virtual host layer, account management, operating system of the virtual host or the virtual guest, security groups, operating system firewalls, and application itself is the customer's responsibility. And we'll really focus on what different controls that AWS provides you in this shared responsibility model to attain that goal. So in terms of the physical infrastructure security, AWS goes through a rigorous set of audits and compliances. So for example, our SOC 1, SOC 2, SOC 3 audits, our ISO 27001 audit certification, and all these audits are really done by third-party auditors, and we take care of them on an ongoing basis. So it's not just we get these audits done and it's a done deal, but it's an ongoing audit that happens on our environments. And as a result of that, with these audit reports that we have, these allow us to really take the controls that we receive from these audit reports and map those to different certifications like the MPAA best practices alignment. And as a result of that, we have a lot of customers from many different industry verticals that require many stringent security control or have stringent security requirements or audit requirements like Sarbanes-Oxley audits, HIPAA compliance, PCI compliance, et cetera, running on AWS today. So it really is a customer-driven improvement environment, and it is security innovation that big firms, small firms, all different types of customers, they come to us with their stringent security requirements. And one thing about AWS is that we really listen to our customers. What do our customers want? And as a result of these security requirements that our customers impose on us, we're building new security feature set, and adding it to the platform. And just by the virtue of the fact that everybody is running on the same platform, your application gets the same sort of security controls that these large companies or other customers that have stringent security requirements, they do. So at the end of the day, everyone's applications are running on the same platform, and you benefit from this security innovation that AWS drives as a platform. So a quick recap of different AWS services that are in use in a typical media workflow. I'm sure you guys been in many sessions today, maybe yesterday as well, and know the introduction about all these different services. So I won't spend a whole lot of time going through each one of them, but kind of wanted to point out that if I was to take different AWS services from the services stack and map it to a typical media workflow, this will be the sort of subdivision that I will see, where I have ingest, different services for ingest that range from computation to different network level services, different storage services that we offer, processing from compute services to the database services and other platform level services, and then finally delivery, where we have our DNS service, Route 53, and Amazon CloudFront, which is our CDN service. So AWS environment was aligned to the MPAA security best practices in October 2012. And this is all based on our shared responsibility model and our SOC 1, SOC 2, SOC 3 audits and ISO 27001 audits, audit reports that we took and mapped those to the MPAA security best practices guidelines. And what we found in that alignment of these audit reports with the MPAA best practices was that there was a one-to-one mapping between what MPAA requires you to be aligned to their security best practices for digital content and what AWS is already doing in the form of these other security requirements. And the scope of the services for the MPAA alignment was all these different services that are listed here. And these map back to the media workflow that I talked about, and that was the purpose of the slide, to talk about that really, all these different services that we see in the media workflow are actually in scope for the MPAA best practices alignment. And in terms of the content types, the alignment was done for all different types of content that range from pre-production, like your storyboards, scripts, your production, like call sheets, raw files, editorials, audio files, to post-production, like actual media files or masters, raw masters, and for distribution, like pre-theatrical prints, etc. And all that was a part of the scope for the MPAA alignment. So what is MPAA content security best practices? I'm sure if you know about the MPAA content security best practices, what it actually entails, you've probably seen this graphic from their website. Don't try to read it because this is hard. Let's face it, this is very hard, especially if you try to do everything from the physical infrastructure security side of things as well. So what I've done here is taken these major pieces that MPAA security best practices are defined in and trying to see here that what different pieces AWS fit into the AWS responsibility and what different pieces fit into the customer responsibility in our shared responsibility model. So the things in orange that you see, like from management systems, organization to management, competency, digital security, content management, content transfer, et cetera, those are all shared responsibility, meaning both AWS and a customer are responsible for these things. Whereas the things in blue that you see, like physical security of the systems, from security of the facilities, asset management, transport, infrastructure itself, those are all AWS responsibility. And just by the fact that your application is running on AWS means that you've already taken care of these MPAA best practices for security at the infrastructure side. So when time comes for audit, it's really a matter of looking at your application, what you've done at your application, and focusing on your application, making sure that it is secure and tight to take it to the auditors to pass the MPAA certification for your application. So AWS physical infrastructure security, how do we really manage and do that infrastructure security? That's not really the scope of my talk here. And there is actually a security track here at reInvent that talks about different things under the covers, basically, that AWS brings to the table or provides you. If you attended some of the sessions, great. If you didn't, the recording of these sessions will be available at YouTube. I'll highly recommend that you go to the YouTube channel, check it out. There's also the AWS Security Center that has tons of information. Our newly available AWS security white paper, which has been updated with the new security controls. I'll highly recommend that folks go there, take a look at it. And also the compliance and risk center that talk about the different audits that we've done to the environments and the audit reports. So what we want to talk about here today is what controls AWS gives you in terms of security controls in this shared responsibility model. So I start here with some of the security controls starting from the the APIs or the access points itself. So given Amazon Web Services, it's all public endpoints that are available to you that you can issue your API request against. They're available via both HTTPS or HTTP or HTTPS using SSL access. Amazon VPC allows you, and we'll talk about in more detail what virtual private cloud is and what it does, also allows you VPN access to your environment. There is a redundant connection to more than one communication service at each internet-facing edge. So meaning any endpoint that we have, there is a redundant connection. So it's built into the service. Any of the API calls that you make to these endpoints that need to be, basically in the case of SOAP requests, that need to be signed using the X509 certs or RSA public keys. And any sort of using the query interface, it has to be have a cryptographic hash signature, industry standard. So for the EC2 instances or the virtual instances that you create on the AWS environment, in order to do an SSH or connection to it, you require a public-private key pair or RDP certificate in the case of Windows instances. And then there is AWS multi-factor authentication, basically where all of your users are required to do an MFA or carry an MFA token in order to log into your environment. And there is a key management and rotation process in place. One key thing that I like to point out here is that with these controls that I'm going to talk about in in these upcoming slides for different services, one pattern that you will see is that these controls are in place not just to give you the flexibility and the security control that you need for your environment, but by default, they move you to these best practices, these security best practices that will help you at the end of the day for making your applications or environment really secure. And some of these are already there that you see, things like MFA, things like key management and rotation, things like require a private public key or RDP certificate to log into your EC2 instances, et cetera. And we'll keep seeing those in the other context of other services as well. Another important service I'd like to talk about here is identity and access management, and there was actually a session on identity and access management in the security track as well. So basically what it is it gives you the capability to create users and then create groups within your organizations and give them the permissions or based on the roles that they're performing. So like your developers can have certain set of privileges, permissions, et cetera. Your network engineers, your system engineers. So based on the actual job role, you can create what type of permissions you want to give to your users or groups via identity and access management. Sort of very similar to the sort of on-prem environment or on-prem sort of controls that you would have today. So identity and access management allows for all users where you're creating logins for them. And those are unique security credentials for each user. There are access keys, unique logins, passwords, and MFA devices that you can enable for each one of them. And we also support federated authentication. So basically, we have a service called Amazon Security Token Service that allows you to use your own identity store. So let's say if you're using Active Directory, LDAP, et cetera, you can use the same identity store, and with the STS or Security Token Service API, create a temporary permission for a particular resource or a function that you want to perform. So the authentication is happening on your end, and the authorization is via the STS that you get this temporary privilege. We also have enabled support for web authentication using Amazon.com, Google, or Facebook credentials. And there is also MFA devices, as I talked about, that you can enable for each one of your users. So there is also policies control access to AWS APIs. So all the APIs that API calls that you're making via your, say, your scripts or your users. All of these API calls must be signed by 509 certs or a secret key. That's a requirement. Otherwise, your API calls won't go through. And also, identity and access management has very deep integration with other AWS services. So it's not just a matter of, say, who has access to the console or whatnot, but it's actually very nice integration with other services like S3, DynamoDB, CloudFront, that we will see in the coming slides, where I talk about security controls for each one of these services. And finally, one last feature, and pretty important one that I'd like to talk about, is the EC2 resource permissions, where basically we allow you to create a role that you can use to launch an instance with. So rather than, so let's say, imagine in a use case where, say, you launched an instance, and now that instance has to go bring some files from S3 or have to access some content in an S3 bucket. Well, if the S3 bucket is secure, obviously the instance, when it wakes up, can't just go and get content from there unless you provide permission to do so. So one way to do that is that you create a role for that instance, which is only valid for this particular virtual server or instance, that when it's launched, it will have access to go get that content from S3 without you having to actually pass in your security credentials like private, public keys, etc. So pretty cool feature there. So EC2 security controls. So EC2, Elastic Compute Cloud, or virtual instances in the cloud, basically give you the capability to launch any Linux different flavors of Linux or Windows instances on the cloud. So basically what's happening is there's a physical host, there's a physical operating system, and on top of that, we have virtualized multiple different slots, and there is the guest operating system. Now, the guest operating system is completely controlled by you or the customer. You have full admin root privileges to the guest operating system. That's how you log into it or SSH into it. And AWS has no visibility whatsoever into your space or into your virtual environment. And you generate a key pair, public-private key pair, that is required to SSH or log into your system. So again, going back to that pattern that I talked about, that just these controls not just give you the flexibility or control that you need, but also kind of motivate you or bring you to use these best practices right from the get-go. Security groups is another important feature within EC2. Basically, a security group is a set of stateful filters within an EC2 instance when you launch it. So on the left-hand side of the screen, you'll see the EC2 instance inside the AWS cloud in an availability zone. And what it really is that it gives you the capability to control both ingress and egress filters in the case of Amazon VPC as to what ports you want to open or give access to, what protocol, and what source. And by default, it's denial. So what that means is that you created an EC2 instance without opening a port, without putting any security group in place. Nobody can do anything to it. Nobody can access to it. Even you as a creator of that instance can't do anything to it unless you explicitly go in, change the security group, that is, give access to specific sources to specific port ranges. So in this example, I have opened port 80, port 1111, 1935 for different applications for public access, and so I can have access to it. If anybody else tries to access on a different port, basically they get denied. So let's talk a bit about the Amazon Virtual Private Cloud. So VPC, or Virtual Private Cloud, is really a networking layer on top of EC2. What this allows you to do is a bunch of different things, actually. So first is that it allows you to create a completely isolated environment inside of the AWS cloud. So basically, you can define your own private subnet inside of a VPC, which is only privately addressable. So that is, it's not reachable via the internet, and it is accessible only via a VPN gateway or over a VPN IPsec tunnel to your corporate data center. So that means that it almost becomes as an extension of your existing data center where you're defining the network ACLs, sort of a concept which is pretty common in the on-prem world, the routing rules, how the traffic is routed from your on-prem world into this private subnet, et cetera, and you have access to both ingress and egress filters that we talked about. So gives you sort of redundant controls in terms of security where you have the stateful filters right next to the EC2 instance itself, and then on top of that, there is the network ACLs that allow you an additional added layer of security. Okay, S3 security controls. So S3 is our simple storage service that gives you the HTTP endpoints, HTTPS endpoints to put objects in there, get objects from it, and scales. So from a security perspective, anytime you create a bucket, or a storage space inside of S3, it is owner-only access by default. So meaning nobody but the creator of a bucket can have access to a bucket. Perform functions on a bucket, meaning put objects into it, get objects from it, or delete objects, et cetera, or whatever the functionality that S3 provides you. Unless the owner of the bucket explicitly goes and opens or provides permission to the other users to be able to use or perform certain functionalities on S3. S3 also provides you both bucket and object level permissions. So let's say if you want to give access to a piece of content or a single file or object to somebody, you can explicitly give access at the object level. Or you can say, I want to give access to the entire bucket, for example. There is signed URL query string authentication that's available on S3. S3 also works very nicely with the identity and access management, as we talked about earlier, and I'll also share a few examples here of how IAM policies work with S3. S3 also gives you the capability to do versioning, so to to protect any sort of like accidental deletions, et cetera. So if any of your users say accidentally deleted a piece of content, it'll delete only that version, and then the previous version will be available for you. And you can also enable MFA deletes on S3, so meaning you require an MFA token or multi-factor authentication before you can actually delete an object. And then lastly, on S3, you can enable detailed access logging. So what that means is that anytime an object is touched, deleted, updated, or meaning put or get, that access or the access logging will capture all the accesses of that particular object. That is, that who accessed that object, who got that object, at what time from S3. A lot of people ask me about encryption, so I put the S3 encryption functionality here. So S3 provides you, I think, if you know S3, you probably also know the S3 server-side encryption, which we'll cover in the next slide. But one important thing also is that S3 also gives you the capability of doing the client-side encryption with the AWS SDK. So imagine you want to upload a bunch of objects into S3, so from your corporate data center. So in this particular scenario, you have to manage a master key that is in your possession. You use the AWS SDK for Java, or AWS SDK, to actually generate a key, a new key. It's called an envelope key, which is going to be used to encrypt your objects. And then you use that master key to actually encrypt that envelope key that you use to encrypt that object. And both your encrypted objects as well as your encrypted envelope key live in S3. And so when you want to, say, do a get on it, basically you have the encrypted file and you have the encrypted envelope key. You use your master key to unencrypt or decrypt your envelope key and then decrypt the content itself. In this case, as I mentioned, you are managing the master key. I don't know if you guys are aware, but also like to mention here that we have the Cloud HSM as a service. So basically, you can use that for storing your master keys or managing your master keys on the cloud as well. So server-side encryption or encryption at rest. So in this particular case, you just simply check in an item when you are uploading your object into S3, which says that I want to encrypt this object, or I want to enable server-side encryption on this bucket. Or if you are using the API, you pass it as a parameter, and it will automatically turn on encryption at rest. So what happens in this scenario is, now imagine you have a bunch of files that you want to upload into S3. S3 has a master key that S3 is managing. AWS is managing that key for you. And there is a key generator within S3 that generates a key. Your files or your objects come in. They are encrypted using that random key that the key generator has generated. And then that random key is then encrypted using the S3 master key. And then both your encrypted object and the encrypted envelope key are stored separately. And when you want to say get this object back, basically you just simply do the get request, and S3 is doing the unencryption behind the scenes for you and returning you the actual unencrypted object. So in this case, S3 does both encryption and decryption for you and key management for you. So you can use both client-side encryption and server-side encryption together to get to this, a more sort of encrypted model, if you will. Very quickly, want to talk about an example S3 policy here. This is an IAM, Identity and Access Management policy. There is a policy language. It's a JSON-based language. There are multiple components to it. There is tons of documentation online on IAM, and you can definitely go there, check it out. But this one particularly gives enables you to give access or public access to your S3 bucket. So the first line there basically gives everybody the access to list all your buckets. The second one does S3 bucket location, basically where that bucket is. And then the third one does S3 put object, S3 get object, and S3 delete object on everything which is underneath example bucket. So in this particular case, it gives public access to do these functions on your S3 bucket. The second S3 policy, this one is basically giving the access to an IAM user only to the folder that has the same name as their username. So basically, it does allow put object, get object version, delete object on the example bucket, and then there is the AWS username function, which actually is the IAM username. So assuming there will be a username folder in that S3 bucket, it'll give access to only that particular user for that folder. Let's talk a bit about CloudFront security in context of your content delivery. So first of all, CloudFront can deliver, has a mode which will allow you to deliver content to securely signed requests only, and that enables you for private content feature. Secondly, you have the capability to do HTTPS only access to CloudFront. And we talked about S3, so just imagine in a model where you have, say, all your objects that are stored in S3 and are being delivered by CloudFront. Now, in order to do that, CloudFront can have edge locations worldwide. One might ask, well, how do I enable access to S3? Because initially we said that S3 by default is owner access only. So there is a concept within AWS or within CloudFront itself called CloudFront Origin Access Identity. I will talk about it in the context of an example as well, where you can create a CloudFront Origin Access Identity that is sort of like an IAM role that you give, that you then enable permissions on your S3 bucket. So if somebody wants to go straight to S3, like a user somehow discovers the URL to the S3 object, S3 will deny access, and the only way to get to that object will be to come via CloudFront. CloudFront only allows you to do HTTPS access from the origins or origin fetches. So origin could be your S3 as storage or EC2 instances or any other storage subsystem for that matter, you can use CloudFront with that. But CloudFront, again, gives you the capability to enable HTTPS access only. And then finally, like S3, CloudFront also has the capability that you can turn on access logs. So what will happen is you turn on access logs, and then you point to an S3 bucket. So anytime somebody tries to access an object, S3 or CloudFront rather will log that information into S3 bucket for you. So here's an example of CloudFront Origin Access Identity. Basically, what I did in this case is I have my content living in S3, and then I have created a CloudFront distribution, and I enabled CloudFront Origin Access Identity. Once I create CloudFront Origin Access Identity for that distribution, I get a canonical user ID that I can then use to put into my S3 bucket policy to allow access to that bucket only via CloudFront. So hence, locking down access to the content directly via the S3 endpoint. So a word on content location. So a lot of my customers, ask me that we have regions, 9 regions worldwide today, in the US, in South America, Europe, and the Asia Pac. So what happens to the content? We promise like 11 nines of durability in the context of S3, EBS, we have some sort of durability characteristics there as well. So what happens? I mean, obviously we're making multiple copies of the content behind the scenes. But one important point to note here is that any one of these regions that you see, the 9 different regions that we have globally, each one of those are independent entities, meaning under no circumstances will move any of your content or your resources from one region to another region unless you explicitly do that on your own. So basically, if you are putting a piece of content in an S3 bucket that happens to be in the US West 2 region, that piece of content will live in the US West region for its life, unless you explicitly take that piece of content and move it to another region. Then how do we get to that durability characteristic? How do we really, manage that? So within each region, there is a concept of availability zones. And the availability zones are really, is a cluster of data centers that are geographically dispersed, but they are interconnected over a private network that allow us to give you the high availability and durability characteristics that we promise. And each one of these regions are built to the same exact security specification. So that's an important consideration when looking into your content security and the content location. So lastly, customers always asked about, okay, it's all great. I have all these nice controls for different AWS services, but how about auditing? How do I know who did what? Yes, I have IAM that I can really pin down who has permissions, who has access to do, what kind of functions or methods within my environment. But what about audits? I need audits. So introducing AWS CloudTrail. Many of you probably saw it in the keynote yesterday, a brand new service that we announced. So basically, your users are sitting there making API calls, all the different calls for different AWS services, EC2, RDS, even creating new users, changing network controls, putting stuff in S3 buckets, etc. So CloudTrail, what this service is doing is basically sitting there and monitoring or logging all that API activity that your users are doing when you initiate it. And then based on once you want to see the audit report, basically CloudTrail will pick it up and provide you the audit report for a particular period of time. So that helps you in many different ways. Basically, if you want to conduct audits for compliance reasons, you want to review the API calls for the users within your account for a particular period of time. You want to monitor user activity for any sort of like suspicious or bad behavior. You can use your security information and event management systems to trigger certain alarms for any sort of like suspicious behavior. And also, given this wealth of useful information that you have sitting in the cloud, you have right next to the other infrastructure like EMR and other analytics, cool technologies, that you can really go and run analytics on it and get something very useful out of it. That how your users are, or accessing or using your resources, your content on the cloud. AWS CloudTrail is free. There is no charge for using CloudTrail. The only thing that you're paying for is when you're storing the data in the S3 bucket and the normal S3 bucket rate supply. So basically, the way you use it is you create an S3 bucket and you give it permission to allow CloudTrail to write to it, because as we talked about, by default, it's owner access only, right? So even for a service, another service endpoint to go right to S3, you have to give permission. And then you specify user-specified expiration policy, where it will expire those logs on an ongoing basis so that you don't accumulate those costs for S3 storage. And optionally, you can create an S3 or an SNS topic, a simple notification topic, which will send you a notification via email or SMS, et cetera, notifying you that, hey, I have received a new log file for the past 15 minutes or whatever duration that you've specified. And all you need to do on your end is basically make a call, create trial, and that will go and start the logging process on our end, and then start logging. So basically, just with these very little, couple of API calls, you can start monitoring the activity of the users on your account and have it accessible to you any given time. So great. We talked about all these neat features, controls within security that AWS provides you. How do you get to this goal of MPAA best practices alignment? So as I talked about at the bottom, starting from the facilities all the way to the virtualization infrastructure, we have done that already. We are SOC 1, SOC 2, SOC 3 audits and ISO 27001 audits. And from an infrastructure perspective, you simply take it and use it as is, that it is already aligned to MPAA best practices, and focus really on the application layer itself, from the operating system to the application itself. And then you can use any third-party auditor to audit just your application. So just imagine, all that infrastructure muck all of a sudden is just gone. And together with this, you can take it to MPAA for the MPAA alignment. So with that, I would like to introduce Ben here on the stage. And Ben will talk about the MPAA alignment for Sony MCS-C application. Thank you, Ben.
Thank you, Usman. Prior to diving into the security-related aspect of this discussion, I wanted to give you a little bit of background and context on the who, what, and why of Sony Media Cloud Services, or Sony MCS. Sony MCS is a new Sony startup. We were incubated a little over 2 years ago. Our mission is to provide on-demand, cloud-based solutions designed to empower media professionals to create and securely manage high-value, high-resolution content. Our origins stem from two internal Sony companies, Sony Pictures, where I come from, where we're mostly in the business of making, marketing, and distributing movies and TV shows. And the second is Sony PSG, or Sony Professional Solutions Group. They're in the business of making professional cameras and other media and entertainment professional solutions and equipment. Over the past several years, we've been noticing a fairly alarming trend in our industry. we've been dealing with an explosion, a literal just exponential growth in the amount of media that our users are consuming. We've pretty much noticed within one studio that I worked very closely with, approximately a 2 to 3-fold year-over-year growth in the amount of data that we need to manage, all media data. A full feature film can generate up towards 10 petabytes of information during its entire life cycle. And all this content, all this material has to be securely indexed, organized, managed, and archived so that the right people can access all of the right content at the right time. So the big idea for MCS was really a fairly simple one. We wanted to leverage our internal Sony digital media know-how, and we wanted to combine that with the power of the public cloud. And so we partnered with AWS to build out an industrial strength software as a service platform and solution set for media professionals. And we did just that. This last April, we announced the grand unveiling of our C product. C, in a nutshell, provides a variety of digital asset management and other media professional tools. Some of these tools allow you to directly interact with the content without necessarily having to download it. You can do things such as review and approve your content. You can do reviews all the way down to the frame level. You can also do things such as basic editing, all in a cloud environment. Our solution is used in a variety of different workflows in the media and entertainment space. We're showing a few of them here, whether it's to review digital dailies for directors, producers, or other studio execs for both TV shows and movies, or C can be used for marketing and stock footage, work in progress, and final asset management. It can be used for disaster recovery purposes. Sometimes it's used to help manage archive content. We're very proud of the fact that just in the last few months, we now have several productions that currently are using C as a platform to manage their content. Usman mentioned earlier that security is a #1 priority for AWS, and we certainly feel the same for MCS. Pretty much from the start, we knew that security would be a very integral part of what we had to build out. We understand the nature and the sensitivity of a lot of the content that goes into this type of system. Some of it involves pre-release materials. And so our architects, our lead developers are actually very well trained on security and understand that security has to be part of our DNA. Pretty much all initial design decisions from an architecture perspective are going to undergo some form of security review. A lot of where we get our guidance for how to conduct security and how to implement security in our systems comes from some of our internal Sony-based information security practices and policies, as well as Usman mentioned earlier, MPAA best practices. We've been helped along the way with a lot of AWS security features. We view those as accelerators. These absolutely help us make a lot of these systems and allow us to implement controls much more quickly. We were also aided by the fact that we actually utilized ISO 27001 certification preparation to help us get there. We were actually ISO 27001 certified this last spring. We also realized that security is not something you start and stop. It's something that's ongoing, and it certainly is part of our ongoing practices within Sony MCS. We routinely conduct vulnerability assessments. We are continuously running penetration tests against our system. And we're very proud of the fact that a lot, thanks to the help of AWS blazing the trail, we now have MCS alignment with MPAA security best practices. This is a very similar slide to what you saw on Usman's deck earlier. And really what we're trying to call out here is so much of what Usman was mentioning, which revolves around the shared responsibility model. It's something we feel we benefit greatly from, especially when it comes to infrastructure security. Once again, the mass majority of our infrastructure is in AWS, and mostly we rely on AWS to make sure that we're secure on all that. In some cases, we have some on-prem and some internal applications where we also need, within MCS, to manage certain infrastructure security components as well. But most of our focus is really then on the logical security. Really, at the application level is where we focus all of our attention. I'll show you in a couple slides some of the things that we're doing in that respect. And I wanted to call out here just one more time some of the AWS accelerators, which once again really just aid and empower us to better secure our systems. Usman did a great job covering these, so I won't go into too much detail. But one of my favorites is just virtual private clouds. That's something we couldn't really do as well or as easily when we were running this in a private cloud. Now we can use VPCs utilizing AWS, and we're very glad we have access to it. When you look at some of the workflows that most media professionals utilize our solution for, they're fairly simple, really, at the core. They're really just a few key use cases that we mostly see. The first is a lot of our creative professionals want to get materials inside our cloud environment. They then want to be able to search, browse, manage, and in some cases preview that content. They want to be able to share and download the content. In many cases, more and more, they want to be able to stream and interact via streaming with that content. And finally, in some cases, now they are beginning to archive their content. And here's my final slide, where I really wanted to show some of the different areas where we are leveraging a lot of what Usman had mentioned before. Once again, I won't go into the details of the implementation of how we're utilizing some of these controls for a variety of reasons, but at least wanted to show you more from an AWS architecture perspective where we are utilizing some of these controls. So authorization and access control, we certainly do use IAM. Also, we complement that with some of our application level authorization and access control solutions. Files that are coming into the system are actually encrypted as part of that transfer. And those files that are encrypted along the way then land in S3. We leverage STS. We also use the server-side encryption that Usman was mentioning. Most files will undergo some form of file vetting. Sometimes we'll go through a file check process, a virus scan process as well. And for streaming, we utilize CloudFront. As of 2 hours ago, we now offer watermarking with some of the streams that come out of CloudFront. We're also using signed URL verification for that. All application-level transactions are being logged within our system. And we will be working very closely with Usman and the AWS security team to also ensure that we get onto the CloudTrail program to ensure that all API-level calls are also logged. So that, in a nutshell, is what we're up to as far as security goes within Sony MCS.
Thanks, Ben. All right, so that was Sony MCS and their path to MPAA alignment to security best practices. So really, in a nutshell, when you're partnering with AWS, it's not just the infrastructure security responsibility that AWS takes care of, the AWS control set within security like AWS IAM, the agile trust zones, including security groups and VPC and the standardized environments. but also a team of individuals that are out there available for you at your disposal, able to help you. The team of solutions architects, professional services, our premium support group, AWS Trusted Advisor Service, which is actually an automated service within your AWS console that notifies you for any sort of security issues that may be happening within your environment, and the growing AWS partner network that give you a wide array of solutions that are built on top of the AWS feature set. So come talk to us. And this is more information, more great information in terms of the Security Center, where you can access the security white papers, the AWS compliance website I talked about, and contact your sales team, and also the Help and Support Center. I really thank you very much for joining us today, and I hope you found this information useful. Myself and Ben will make ourselves available here for any sort of question and answers that you guys might have. Thank you very much.